So these are the transfer functions. Apart from these, there are linear functions or radio basis transfer functions. In solving certain problems, one neuron may not be enough, so we have to establish a network based on the neurons. We have interconnections of different neurons, and we call this one the node. And we can say that this part is the input layer, and this one we call it the first hidden layer, where there are several neurons. We call it node. And the second hidden layer, and up to now we should have output layer. So this kind of thing we call it feed-forward neural network structure. How can we use this kind of structure? Suppose we have a certain amount of sample sets, just like we have used in data fitting problems. We have certain amount of data files. From certain inputs, we can measure the output, the value of the output. So how can we use this neural network to fit or to approximate this kind of behavior? What we need to do is just divide randomly the samples into two halves. Suppose we have 2 times n set of samples. So we can randomly select n set of samples and use this n set of samples to train the neural network. That is, to find the weightings and the transfer functions in the neural network. So the first thing we need to do is to create a neural network like this, and then we should select part of the samples to train the neural network. And then we should use another half of the samples to validate the neural network, to see whether the weightings are correct or not. So we can have 3 stages. One is to establish a neural network, and then we can train the neural network, and then we can validate it. So there are 3 stages in neural network applications. And this is a general description to it. So now the problem is, how can we solve this kind of problem with the use of Matlab? Actually, in this problem, in this example, we do not have to follow all the 3 steps. Let's go to this part again. Okay, are you going to set up we can draw the samples as we did in chapter 8. Suppose we can generate these samples by certain functions. So the problem now is, how can we find the fitting curve by the use of neural network? If we are trying to use inter-P function, it should be okay. But the problem now is, how can we fit this kind of sample data using neural networks? And the first step is, how can we establish a neural network? For the neural network here, we have only one input signal, which is X, and the other one, there's only one output, which is Y. And inside the neural network, we can establish one hidden layer. And suppose in this layer, we have 5 nodes, or we have 5 neurons. And we can adjust the number of neurons later on. Then we should have combinations, we have connections like this. And in each of the connections, there should be a weight. And also for the output layer, there's only one node because the output has only one signal. So we should have connections like this. This is V1, V2, and V5. So this is the problem we are supposed to solve. Based on the sample point X and Y vectors, how we can train the neural network so that we can find a good combination of the weightings. So this is the first step. How can we establish? I think the first step is to create the neural network. The second is how to train the neural network. And third is how to validate the neural network. So the first step is how can we establish a neural network like this? To establish a neural network, the functions we have to use is something like this. Net equals to new FF, which means feed forward. The network here, we are using so-called feed forward network. So we have full function new FF, and we have to specify the range of the input signal. And then we can specify the hidden the nodes in the layers. And then we have to specify the transfer functions in each layer. So for our example, according to the command like this, what we need to do is to use the command new net equals to new FF, and then we have to specify the range of the X signal. And then we should have 5, 1 here because we have 5 nodes in the first layer and 1 node in the second layer. And then we should have the transfer function. We can use log signal. Of course, we can use different kind of transfer functions. So we can use a command like this to establish a neural network system. So we can use net equals new FF, and the range of the signal should be from 0 to 10. You can see from the scale here, 0 to 10. And then we have 5, 1 as the input nodes. We have log 6. We can also have different kind of expressions in it. So in this case, we can establish a neural network object, NET. So this is the first step. The second step is how can we train the neural network? To train a neural network,